إلا صرت في مان يا أخي دوس عندي خوش فصلة.
So hello everyone. So we are today doing the second lesson of the science chapter book periodic classification of element. We have completed the first chapter of gravitation in the previous video. So today we will be starting with the important topic from the second chapter. So our topic for today is the electronic configuration of element. So first of all, what is an element? So element is anything that we can found in nature. So for example, if we take oxygen, which we see it in atmosphere, it is an element. Carbon, which is found in diamonds, it is an element. Nitrogen, sulfur, so everything which is found in the nature, may it be in the solid state, liquid state, metallic, non-metallic or gaseous, it can be called as an element. So what is exactly an element and what is its electronic configuration? So electronic configuration means how many electrons are present in that atom. So we have studied solar system in 6th or 7th standard. So this is a solar system and the sun is in the middle. So just like that, the element, the nucleus of the element is in the middle. So sun acts as a nucleus and there are planets like Mercury, Mars, Earth revolving around the sun in their orbits. So if we see element under a compound microscope, we can see the structure of the element is something like this. So in the center, this is a nucleus. We all know that there is nucleus in every plant and animal cell. Even in our body cells, there is a nucleus in each cell. So these nucleus, it consists of protons, neutrons and electrons. Protons are positively charged. So you can remember P, positive proton. Neutrons are neutral, N. And electrons are negatively charged. So to balance, if there are 6 protons in the nucleus, there are 6 electrons in the orbit. So plus 6 minus 6, they would cancel each other and the element becomes stable. So for carbon, the atomic number of carbon is 6, which means that there are 6 electrons in the orbit of carbon. So as we have the orbits for our solar system, we have 4 orbits. So first orbit is named as K, L, M, N and so on. So as the number of orbit increases, we give them alphabetical letters like N, O, P, Q, I, S, T and so on. So today we will study only the common elements. They have only 3 or 4 shells in their electronic configuration. So for carbon, there are 4 shells. Now how we gonna write its electronic configuration? So atomic number is 6. It means it has 6 electrons and 6 protons to neutralize. So always remember that the number of protons is equal to the number of neutrons. So if there are 6 protons in the nucleus, there are 6 neutrons which are negative neutral. So 6 neutral neutrons, 6 positive protons and 6 negative electrons. So what do these electrons do? These electrons revolve like planet around the nucleus of the element. So there are 6 electrons. So each shell, each orbit has its own capacity to accommodate the electrons. So we'll see what is the capacity of these orbits. So there are 6 electrons. We have to accommodate these 6 electrons into this shell. So the capacity of K, L, M, N shell is 2, 8, 18, 32. It means there can be 2 electrons in the first shell, 8 electrons in the L shell, 18, 32 and so on. So how do we come to this number? So there is a formula 2n square. So if we put the number of orbit in the at the place of n, we can get the number of electrons. So the K shell is the first shell. So if we put 1 here, so 2 into 1 is 2. So hence there are 2 electrons. If we put 2 here, the L is second number shell. So if we put 2, 2 square is 4 and 2 into 4, 8. So by putting the number of orbit in this formula, we can get the electrons. Okay, so the K has capacity of 2 electrons and we have 6. So we'll put 2 electrons in the K shell. So after we have put 2 electrons in the K shell, the remaining are 4. Okay, so 4 electrons are remaining. So capacity of L is 8. So we can put only 4 because we have 4. 1, 2, 3, 4. And that's it. This is the electronic configuration of carbon. And the correct way to write is electronic configuration. We write in brackets. So first shell has 2 electrons, comma, second shell has 4 electrons. And this is the way to write the electronic configuration. So if this question comes in exam, that write the electronic configuration of these elements, this is the correct way to write them. And if we add these electrons, we get 6, which is the atomic number of carbon. Okay, so let's do it for magnesium. So magnesium has 12 electrons. So we'll start filling the shells. So first is K, L, M and N. So in the first shell we have capacity of 2 electrons only. So 12 out of 2 will be in the K shell. Then 12 minus 2 is 10. So the capacity of L is 8. So there will be only 8 electrons in the L shell. So out of 10 we have used 8. So how many are remaining? 2. So there will be 2 electrons in the M shell. So what will be the electronic configuration? First shell has 2, second has 8 and 2. So this is the electronic configuration of magnesium. Okay, so you can write this in the exam if it comes. So you all do for argon. I'll just help. So argon, it has 18 electrons. Similarly, it has 18 protons in its nucleus. So we'll now fill the electrons in the shell. So K, L, M, N. K has capacity of 2 electrons, so 2. L has capacity of 8 electrons, so 8. So total there are 10 electrons, we are left with 8. 18 minus 10 is 8. So we fill 8 electrons in the M shell and now it is filled. So the electronic configuration is 2, 8, 8. For argon. So in the exam you will be given the name of the elements and their atomic number, which is nothing but the number of electrons in the shell, and you have to write this electronic configuration. There is no need to draw this diagram, but if you draw this diagram it will be well and good. So you can try for sulfur. It has the symbol S. You can try for sulfur and try to find its atomic number and also draw the electronic configuration and comment down its electronic configuration in the comment section. Thank you. I hope you understand this topic.